But let's start with Leetlib. Continuing our way through the grind 75, we're up to week 5, problem number 7, accounts merge. Problem 721. Given a list of accounts where each element accounts sub I is a list of strings, where the first element accounts sub I sub 0 is a name and the rest of the elements are emails representing emails of the account. Now we would like to merge these accounts. Two accounts definitely belong to the same person if there's some common email to both accounts. Note that even if two accounts have the same name, they may belong to different people, as people could have the same name. A person could have any number of accounts initially, but all of their accounts definitely have the same name. After merging the accounts, return the accounts in the following format. The first element of each account is the name, and the rest of the elements are all emails in sorted order. Okay. Accounts themselves can be returned in any order. All right. And then we got a couple of examples. I'm going to check the constraints. You can have up to 1,000 accounts. Each account can have 10 emails, up to between 2 and 10 emails. And each email is going to be between 1 and 30 characters long, if I'm reading that correctly. What kind of email address is 1? Okay, anyway. Accounts I sub 0, which is the name portion, consists of English letters. And then accounts ij for all j is greater than 0 is by an @ sign followed by a single character followed by a dot top level domain, which I think the shortest one is 2. So that would be 2 plus the dot, 3 plus letter 4 plus @ 5 plus first character 6. So 6. I think 6 is the smallest one. All right. Oh, let's set up. This is a problem. What was it? 721. Yeah. Right down here. 0721 accounts merge. All right. Let's create the file and jump to it. Grab this. We got to say pub struct solution. Paste that in. Open vec new to get it to build, and make sure it builds over here. Okay. So we're going to grab this as our test input. Where is it? Here it is. And create a test. ex1. And let's just set it up this way. I'll just paste it. And then we'll let Rust format it for us. Do this, back bang, back bang, back bang. Oh, did I grab the, oh, I did grab the output. We have to do a string like that. Can I do this? And then to string here, and then to string here. Okay. And then we do need the output vector, right? Let output is equal to, and we had that here. Vec bang. Semicolon. And these also need to be two-stringed. Okay. And we got here, and here, here and here. Okay. The only problem is the expected versus actual. This says that accounts can be returned in any order, but then emails need to be sorted. So the emails are going to be fine. It's just the order in which these appear is going to be random. And I think I had in my utils, there it is, vec. Yeah, a little function that allowed me to compare two vectors to see if they're equal. By hashing one and then figuring out the hash of the other. So we can see if that'll work. Let's do it this way. Nope. There we go. Vec, yeah. It's just called vex equal. Okay, so let's see if we can grab that. Assert vex equal. How do I I've forgotten how I reference it now. But I should be able to do like an import, right? Use create utils vex equal. I think. Let's try it. And then this is going to be solution, : something, accounts merge. Of input, gonna match output. All right, let's see if that does, if that builds. What was this saying? Input. Oh, did I not call it input? Let's see. I called it, oh, I called it accounts. And vex equal arguments to this function are incorrect. Oh, do I have to pass in a reference? Yeah, okay. All right, so it panicked that assertion failed. Okay, so that's because one side is not equal to the other. It would be nice if vex equal could actually tell me what's not equal. Because right now all it's saying is that I was unable to generate output. So let's what we can do is just println. Let's grab it. Let result is equal to this, right? And then we can just say this result. But before we do it, we say println result. That way we can actually see what's going wrong, right? And now we see that we have an empty result. Okay, so now we just have to solve the problem. So how do we do this? I guess the first approach would be, or one approach would be to create a struct which contains yeah, so if we create an address struct which contains the name of the person plus all of the email addresses associated with that person, and then we can create a function which will add those names or add emails. If there's one email in common, it can add an email to it, right? Here we can see John Smith at mail.com and johnsmith.mail.com at mail.com. So we could just add, say, you know, can you merge this guy? And if so, so we can do a struct address. Name is a string, and then address is going to be a hash set of string. And now that way I can say if the name is in the address, then we can merge the account. Impl address. first we'll create a new, right? Oh, that's right. So we're going to have to figure out when do we want to create a new one? Do we want to do it this way then? Or just create a hash map here? Address book is a hash map of the name of the user followed by, and it could have multiple names, right? Because this guy, this John, is a different John to this John, right? So these are two different Johns, but these are two of the same Johns. So we can have a vec of addresses, and the address just has the set of addresses in it. So that's all that is. Do I actually want to create? Well, let's see. Let's see. If we do this, this should be a colon, hash map new. And let's delete that. And then we're going to have to add our hash map and hash set. There. Okay, and now there's a bunch of stuff we're not using. Okay, so the next thing we need to do is go through all of the accounts. And we're going to create a new, we're going to look in the address book to see if we already have somebody with that name. And then we'll loop through all the addresses to see if we need to merge with somebody who already exists or create a new one. So those are our two options. Let's start off saying let name is equal to account of 0 dot clone. So this way we have a copy of the name that we can put into our hash map. And now we can look in the hash map to see do we use the entry API, or do we use right, if we can say if let no we could just say let entry is equal to address book of name, no, address book entry of name, or there's an or default, right? Which will, what that'll do is it'll generate, right, a mutable reference to a vector of addresses. And now we can loop over all of the addresses to see if we need to add something. So we can first start off with this, adding a new entry. If an entry doesn't exist, it's easy. We just stick the account names in there as a hash set of So let's create a little impl on this guy. We can give it a new with a name. Oh, we don't need the name. We just need the an array. Ooh, how do we want to do that? Because we want to clone out all of the strings, I think. We're going to put them in the address as a hash set. So I think what we need is like this, right? Self. We just say self enter. And that's all we need to do. And we can say entry.push address.new colon new of our hash set. And let's just generate that here. Because we're going to need it in more than one. How do we do that? Can I say count? One dot dot, and then iterate on that. Merge Oh, yeah, merge with existing or create new. That'll be that one. And then, yeah, so what do we do here? Is this something we can say hash set from iter? Oh, what goes here though? Cloned. Let's see what blows up. Oh, this is a thing of strings. So can I say iter cloned? I can. All right. So let's separate those. So now we have the name and a hash set of all of the emails. If we're creating a new one, we got this. I guess what we can do now, right now we're generating an empty array. Right? Let's see what would it take to generate, just to see how far we got with this part of the code. Let's see if we can convert this hash map now back into a result vector, because this is what we need, right? So we need to create a new vector, and then we're going to iterate over the hash map key val in address book. For each key now, we're going to add we're going to create a subarray, right? So let's call this address. It's going to be, we're going to start off by using the username, right? So the output here is John, and then it's going to have all the email addresses for John. Okay, so that's the first thing, and that's actually just the key. So we could say vecbang key clone. Key is a string, so we're going to clone that into here. And then the value should be a vector of addresses, right? Which we can ask the address code to just return us a vector of all the entries in the hash set, right? Fn get list self vec. Oops. Hotkey vec string. Okay, so now all we need to do is walk the hash set and generate a vector of strings from it. So can we do that? Can I say self adder iter collect? Can I do that? Is that all we need to do? I need to, oh no, that should be fine, right? And then I can call it let emails is equal to val.getList, getList, address extend emails. I can combine these into one statement, right? But let me just see if that works. It doesn't like get list. Oh, it's not found on vec address. Oh, right. So we have to do it for each one of these. Okay, so for entry, I don't want to use entry, but I will in val. So we'll do that entry. And then this gets appended result.push address. And this returns results. Okay. How close are we? Vec can't be, oh, because it's that. So can I say cloned here too? Clones. All right, so we actually have something here now, right? So we have John and Mary. We're missing the other John for some reason. Oh, because that's probably through the else clause. Okay, so we're actually getting something. That's good. Is it in the right order? Oh, it's backwards. Oh, right. that's right. This has to be sorted. So let mot list is equal to this, and then we can say list.sort list. So now it should be sorted. Oh, can't do that. Type must be known at this point. But okay, so it should know that list is vec string based on the return type. Vec string. Okay. Yeah, John New York, John Smith, and yeah, so that's sorted correctly. Okay. So now all we need to do is figure out how to merge with an existing email address. To merge two addresses, we first have to see if any of the addresses overlap. Right, and that's where the hash set's going to come in handy, is that we can just compare them to see if they intersect. And actually, let's take a really quick look at the hash set API to see how intersection works. Because we should be able to, yeah, we pass in, we say, does this other set intersect with our set? And if there is an intersection, oh yeah, so this returns an intersection. I wonder if we can just do an is empty on it. What options do we have for intersection? We have clone from, format, next, size, hint, count. We can count them. I just want to see, is it empty? Is there an is empty on this thing? Because if we do an intersection and the intersection is empty, then we have a new all any find map, try find, position. No. It's sorted. And then we have these things. So we can't see if an intersection is empty. That's a shame. No. We can do a count, right? But then it's just going to count how many are in there. Consumes the iterator, counting the number of iterations and returning it. We could say if the count is not 0. It seems kind of lazy, but all right, so else. Okay, so now we're going to iterate over all of the entries in our array. So we can say for E in entry, does give us a mutable, yeah, it gives us a mutable address. We can now say if E dot intersects with adder, then E dot merge adder, and then what we can do is I guess we can do a found, right? Let mot found is false, found is true, break, and then here we can say if not found, then we have a new address. So we can say entry dot push address new adder. This might give us a lifetime issue or a consumption issue or something like that. And we don't have intersects or merge yet, but we'll write those in a second. Let's just stub them out for now. Fn intersects self other hash set string returns a bool, and I'll just say false, and then oops, and then merge, and it doesn't return anything. Merge other into self.adder. Okay. Oh. Like that. And then same with that one. Okay, so here we're having a move occurs because this entry has this, which does not implement the copy trait. Right, so do we need to do this? Can we do this? Iter moot. We can. Okay. So we're getting closer, and now we can see the other John in here, right? The only thing we're not doing now is merging. Right, so we have a John, and a John, and we need to merge these first two ones. So now we just need to see if they, actually, you know what we could do is we could just combine these two. We could just say try merge, right? We can say if e.try merge adder then found is true, right? We don't need to check if it intersects and then merge it. We can just do it all at once. And so this changes into try merge. So now all we need to do is figure out how to merge two hash sets together. So we say if self adder intersection other dot count is not equal to 0, else false. True. And we just need to merge these now. Self adder, oh, this needs to be mutable. Self adder let's take a quick look at the hash sets. Oh yeah, so we want a union. Oh, but then it returns this union thing here. So we'd have to reset it this way. Okay. A union B collect. I mean, we could do that. It might be a little slow. A self adder union other collect. Let's see if that builds. It does not. This is a reference. This is a reference to hash set of strings, and it's saying that I can't do this. Oh, do I need to? Yeah. Do I need to clone these again? That's bad. I don't want to have to go through that mess. All right. Well, the test passes. I mean, that's the good news, is the test passes. We can throw this at Leetcode and see if this is good enough. But it would be nice to be able to do this without cloning. I should just be able to merge it directly into adder. I can just loop over other and say self-adder.insert. Let's try it this way first and then see how this goes. Let's copy this and put that right down here. And then go to the top here. I want to actually put this in this order here so that I can copy this and put this up here. Boom. Okay. So we have our address thing here at the bottom, and we have our accounts merge here at the top. All right, let's see if this is good enough, or maybe it's too slow. Compile error. What did I miss? Oh. Okay, let's throw that in there. Happy to do that. I guess the newer version of Rust doesn't require that. So let me just throw that in here too, because obviously we have a bug that's causing some issues here. So for accounts is this is what I output, and this is what I should have output. Okay, so let's add this as a failing test, and then try to figure out why it failed. Test fail 1. So this is let accounts equals this semicolon. Bang. Exploited kernel. Thank you very much for the follow. Exploited kernel. That sounds dangerous. Okay, so we have this. We can just toString all these guys. Oops. And do it here. And do it here. And then we're expecting... All right, and then all of these get toStringed. Right, and then we're going to put, and we're going to assert that our vecs are equal. Let me get rid of this line here and put it here. Result equals solution. Accounts merge of accounts. Is that all I did? Yeah, and then just vex equal. Okay. Result and output. Okay, so let's see if we can reproduce the bug. Oh, need a let keyword in there. Okay, so yeah, it generated 2 different Davids, which I think is exactly what happened here. Yeah, so it created 2 different Davids. Even though they have an email address in common. Looks like David2 at m.co is common. So that means we're not checking for commonality correctly here. Let's do it one step at a time. We'll just print out how we're handling it, and we can see what's going on. So after we're all done, println, we're going to say println name, name with the address as adder, and it's going to generate adder book. And let's see what's happening. Did I mistype that? It's right here. Oh, address can't be formed. Okay, okay. And now there's a move. Okay, because we're inserting it here. So I can just say this counts 0. And now we're using it here. We're passing it in here. Okay, so that means we have to just change our API. Can I do it that way? Then I'll have to clone it, right? I can clone it here, and we'll get rid of the clone. Oops, where am I doing it? Oh, right here. Okay. I can get rid of those clones after we're done debugging. All right, so with the David, with these 2 addresses, we created a new David with these guys. With David 4 and 3, so now we have, oh, I see, okay. So now what's happening is we have 2 separate Davids. And now the next one that merges is going to find it, right? because we have a David with this set of addresses and we have a David with this set of addresses. So we have to say after each merge, we have to say, oh, does this allow us to merge existing ones? Well, that's a pain. So if it's found, now we have to loop over each one of them and see if we can merge the two. Oh, all right. What's the easiest way to do that? So if found and do this, else we're going to just create a new entry. So we need to loop over all of the entries again for E in entry iter mute. Oh, we need to know what entry we found, right? Because once we found, okay, so then we should do this up here. Maybe that's, we're getting a little too nesty now. But if we're able to merge, then we want to do it again, right? So for E2 in entry.iter mute, I don't know if that's going to let me do that. Right? Because now I'm iterating a second time on the entry. Oh, I know what I can do. I can cheat. Let mod iter is equal to entry iter mute. And then I can say while let sum E is equal to entry.next. Oh, iter next. There. And now I can just continue the iterator here, right? Because we're going to break out as soon as we're done. And I can say while let sum E2 equal iter next. Okay, now we're going to see, does E2, can E2 merge as well? And if E2 can merge as well, then we need to merge E2 and E together. All right, so this is where having an intersection code might come in handy. Fn can merge self, other hash set string. Oh no, we can just compare it with another address because it's just E and E2, right? Bool. And that's where we're going to do this self adder intersection other adder merge with E2. Is E2 already a reference? It is. Okay. Then what we're going to do is we're going to say E dot merge from E2, and then we're going to clear out E2, and then we're done. And then down here we have to look to see if the val is empty or not. I guess we don't. Right, because if it's not, oh yeah, we have to say if val, yeah, okay, so let's leave that alone. And this is, we're going to merge from now. Fn merge from self other address. Doesn't return anything, but it basically just does this. And now we have a whole bunch of duplicated code. Oh, yeah, and then I got to write it clear. Oh. Okay. Self is a, oh, we need to make that mutable. Okay. Oh yeah. Okay, so I did. That's what I was thinking. Okay, so if the entry is empty, then we got to ignore it. So val is this. We can say iter filter v not v is empty. Can I do that way? Okay, and then create fin is empty, self, bool, adder is empty. Self adder is empty. Okay, now it passes. All right, so this is a little bit longer than I was hoping for, but there it is. Let's get rid of these printlns. All right, and now that all stays the same. I can just grab all of this and come down to here. And then where's result? There it is. So we can just paste all this in. Paste. And then the other thing was the address. Let's just grab the whole thing so I don't forget anything. And it all fits. Don't need the debug. Let's grab all of that, paste that in. There's clear merge from, okay, let's see if this works. Oh no. Failed to resolve. Oh, did I? Oh. That was dumb. I blew away these two lines. There we go. Okay, so that was accepted. Now what did I change here? Nothing. All right, how did we do in terms of, oh, not very good. It's slow. Maybe because of all the cloning? Yeah, okay. I'm not gonna worry about it. I solved it. There's probably a better way to do this rather than this, because this is like O of n squared, right? Because we're looping over all of them and then looping over the remaining ones. Well, that's n. That's n, right? Because we're only going through the loop once. Maybe hash is slow. Maybe all the cloning is slow. Oh yeah, I was going to get rid of the clones because I don't need to do that without the print statements. We don't need to clone it. Let's go back to my solution, which is here. Maybe that'll help speed things up. Here. Oh wait, I forgot that. That's not going to compile. Got to get rid of those guys as well. It didn't change the speed at all. So the cloning, maybe Rust was able to optimize out the cloning. Anyway, it works. I'm happy. Let's go to Clippy. Clippy says try iter by ref. Huh. Okay. And that's on the inner one. So I can say for e2 in iter by ref. Clippy passes that. The tests still pass. Okay. So that's interesting. Yeah, let's status git add source git commit -m problem 721 accounts merge. All right, so that's that one. And that took me almost an hour, Maybe it'll edit down to 45 minutes or so. We'll see.